Hello friends, in this video I'd like to solve the following problem from Joseph Gillis Mathematical Olympiad 1995, problem number 1. We want to solve the following system of equations. X plus logarithm, presumably of base 10, it may be natural log, it was not stated exactly in the problem statement, so I'll assume that it's decimal logarithm of x plus square root of x squared plus 1 equals y, and so on, cycling through x, y, and z. So we wish to solve the following system. Here are my hints. Crucially, prove the following lemma that if t is a positive number, t plus decimal logarithm of t plus square root of t squared plus 1 is greater than 0. It also works for natural logarithm. In fact, it's true for every logarithm with base greater than 1. And after proving this lemma, consider separately cases of positive x and of negative x, and try adding equations together. So give this problem a try, and I will see you in just a minute. Okay, so first thing which I wish to do is to prove my lemma. I wish to prove my stated lemma. So let's do it. Proof. Proof is very simple. Let's take a look at our function. T plus decimal logarithm of t plus t squared plus 1. Let's take a look. This function over positive numbers, in fact over all real numbers, it's increasing. Here we have another increasing function, and since t is positive, t squared is also increasing. T squared plus 1 again increasing, square root of an increasing function is again increasing. Sum of two increasing functions again increasing. We know that decimal logarithm, and in fact every logarithm with base greater than 1, is also increasing. So this thing is also increasing, and finally this is also increasing, because sum of two increasing functions is again increasing. So after writing all of that, maybe you know I will write in the following way: function which takes positive numbers and maps them to this is increasing. It was justified. Is increasing, and moreover it attains 0 at t equals 0. Why is that? Well, if I plug in t equals 0, I have 0 plus decimal logarithm of 1. It's 0. And that means, since our function starts at 0 and it's strictly increasing, maybe let's add it, it's strictly increasing, that means obviously that for every t greater than 0, our function is in fact greater than 0. And that closes the proof of our lemma. Okay. And now let's consider our system of equations. I will write them. Here is our system of equations. And now I wish to consider two cases first. Case number one. Case number one, when x is actually positive. Well, by our lemma, this thing right here is also positive. It's again positive. So that means that y is positive. And again, by our lemma, that means that this thing right here is positive, and that's z. So z is positive as well. Okay, but that means after adding these equations together, after adding, let's say, dot, double dot, and triple dot together, we will get the following. Well, after adding together, we will have x, y, and z, and on the right-hand side, we will also have x, y, and z. So we will be left with decimal logarithm of x plus square root of x squared plus 1 plus decimal logarithm of y plus square root of y squared plus 1. And finally, decimal logarithm z plus square root of z squared plus 1. And I run out of space. Of course I did. Equals 0. Is it possible? No, because we are dealing with positive numbers. So this is strictly greater than 1. This as well. And this as well. So we have 3 positive numbers, and we know that sum of 3 positive numbers cannot be equal to 0. So it's impossible. Contradiction. It's contradiction. Very well. So x cannot be positive. So can x be negative? Let's say case number 2, when x is actually negative. What happens then? Well, let's take our system of equations to get again. Okay, so here's our system. And now let's take, let's see. I wish to state it in the following way. I will put everything everywhere minuses. In other words, I will negate both sides. So I have minus x, minus 1, minus z, minus logarithm, minus minus, minus y, minus z, minus x. Very well. And now what happens? Well, let's take a look. Here we have minus x. Since x is negative, minus x is positive. And moreover, I will do the following trick. Minus logarithm, decimal logarithm of x plus x squared plus 1. Well, it's the same as decimal logarithm of 1 over x plus square root of x plus 1, sorry. And then, well-known trick to be made, I will multiply both my denominator and the numerator by square root of x squared plus 1 minus x. And what do I have? Well, I have decimal logarithm of minus x plus square root, and instead of x I can also put minus x, because we know it's the same. The denominator is 1. So our system of equations can be written in this way. Minus x minus 1 minus z minus y minus z minus x plus 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 decimal logarithms and here we have minus x minus y minus z plus square root of something. I will fill in the blanks in a moment. Okay, and let's notice that we have exactly the same system of equations, but with every variable negated. And again, we can play the very same game. Since minus x is positive, minus y must be also positive, and that means that minus z is also positive. And again, we have no solutions. We have exactly the same after adding our equations together. Another contradiction. Another contradiction. And finally, the last case. So x cannot be positive, cannot be negative, it must be 1. Case number 3 and final case, when x is actually equal to 0. What happens then? Well, should be pretty easy to see that if x is in fact 0, then y is also 0 and z is also 0. Then y is also 0, and finally z is also 0. And it should be evident that in fact this is a solution. Moreover, it's the solution because there are no other solutions. The only solution x equals y equals z equals 0. And that's it. That's the only possibility. As I have stated, my reasoning was valid for decimal logarithm, but actually it works just fine for every logarithm with base greater than 1. For natural log, it works as well. For binary logarithm as well. Yes, that's it. So, thank you for watching, and I will see you next time. Have a nice day.